this tool is useful for.
Okay, thank you. Well, hi everyone. So I've been introduced, so I don't have to say my name again. It's nice. I've been here last year and I introduced OpenNebula. So I changed a bit the presentation, so I give more insight of OpenNebula from different perspectives. From the consumer point of view, the cloud integrator point of view, and also from the cloud administrator. So, what is OpenNebula? Okay, so if you want to use virtualization or cloud technologies, it's because you're looking a way to flexibilize your service, right? To make them elastic. So at the beginning, you can think, okay, I'm going to decide for a hypervisor technology, and why do I need a virtualization manager? Well, what is all that about? Well, you obviously, if you have a small number of VMs, you can decide that okay, I'm gonna handle those manually. I'm gonna have an Excel spreadsheet saying, okay, this VM is in this host and it does have this IP and is using these disks and so on. But that doesn't scale. I mean, if you are trying to run a big cloud in a large number of physical hosts, then you will need something to take care of those details for you. So what are those details? Well, as I said, where do I put my VM? What's the best available physical host where my VM is going to fit and is going to perform right? Okay, so that will be scheduling. For scheduling, you also need information about the state of your physical infrastructure, so you need to monitor that. Okay, so OpenNebula also does that for you. Also, how do I provision a new VM? Where do I get the images from? Where are they living? How do I fit information to that VM? Well, that would be image management and also contextualization of the VM. And again, OpenNebula gives you means to do that in an automatic, even graphical way. Also, you may be interested in offering your cloud to other people. So how do I manage the users? How do I manage the roles? Can I create groups? Well, you get the user management. Also, what if I want to create new disks? How do I do that? You need some kind of storage management as well. Again, you may want your VMs to be completely isolated, but in most of cases, you'll want to have some kind of networking. How do I handle that? Can I put VLAN tagging on my VMs? How do I do that? Well, again, you need a virtualization manager. Do I want to use more than one hypervisor? If so, which ones are supported? Well, we'll talk a bit about that afterwards. And of course, you want to manage all that through a clean interface, or maybe you want to do some scripting to automate some common tasks. Well, OpenNebula offers a wide range of APIs for public and also private clouds, and three different interfaces, two of them graphical and I think very comprehensive and complete command line interface to manage all the resources that are available on cloud infrastructure. Okay, so if we combine all of this together, we got a uniform management layer that orchestrates multiple technologies to form, basically build clouds. And that's what we call the OpenNebula project. Okay, so what do I say that OpenNebula, it's a solution to build clouds? Well, it's a solution to build clouds and also it's a solution to virtualize data centers. The philosophy behind OpenNebula is not that you should shape your physical infrastructure around a virtualization manager, but rather the virtualization manager should be able to shape itself to integrate with existing technologies you have in your data center. I mean, we know that each data center is a completely different world, different technologies, different hardware layouts. How do I deal with that with a completely closed product? Well, the answer is that you cannot. You need something that is more like a toolkit. Bad thing about that is that it's not a closed product. So if you download OpenNebula and you try to build a cloud in like 5 minutes, it's gonna be tricky. You will need to fine-tune different components, different plugins. Everything in OpenNebula tends to be modular and plugin oriented. So at the end of the day, you have like little scripts that do little actions for a specific technology, more or less how the Unix philosophy is, small commands for small tasks. Okay, so with OpenNebula you can build a private cloud if it's only about your data center or physical infrastructure not being devoted to external users. You can turn this into a hybrid cloud if you use some of the OpenNebula hybrid cloud adapters to be able to interface with public cloud services like Amazon or like Elastic hosts. And if you activate one of the several public interfaces, you can get a public cloud, and you can shell your physical infrastructure or offer your physical infrastructure to external users in a controlled way, not offering details about your infrastructure that you may not want to disclose. So OpenNebula is a fully open source project. It's based on the Apache license, which is very unrestrictive. It's made to be interoperable with different technologies, also kind of based on standards. So we always try to not to make up some APIs or whatever. We always try to find whatever is there, whatever people use it, and plug it in. Tends to be infrastructure agnostic, so at least the core is. I mean, the specific drivers are talking with specific technologies, but for the core, everything is like an abstraction. So you can really say that that will foster the integration with new components. It's also a proven technology, meaning that it's been around for, I think, 4 or 5 years now. It's been used a lot with big deployments, which kind of prove that it's scalable, at least if you have the configuration right. And also it's flexible in terms of integration with new technologies. Okay. So what is OpenNebula for different stakeholders of the cloud? Well, you can have 3 big types of people that will be interested in OpenNebula. Probably the less interested will be the cloud consumer, but they are the end users of the cloud, the one that uses OpenNebula just to get raw computer power out of any infrastructure. So you got the end user, you also have the cloud provider, which is the one that enables their infrastructure to be cloud-like and offer that to external users or internal. And you've got the cloud integrator, which is someone that's trying to build cloud solutions, and it may want to integrate OpenNebula with some other technologies, like some billing platform or any other hypervisor, any storage backend that is not currently integrated, you name it. Okay, so from the cloud consumer perspective, from the end user perspective, the guy that is gonna use the cloud, what are the components? What are the managers that he's looking for? Well, he will probably need to do some, well, obviously need to do some kind of virtualization management. Like, for instance, he will like to manage the complete life cycle of a virtual machine, meaning being able to launch it, stop it, suspend it, shut it down, migrate it, Although, well, migration would be just for private cloud. It doesn't make sense in a public cloud interface to have a migration. He would like to maintain a catalog of templates of VMs, so he can keep track of the different VM configurations he has. He also may want to use contextualization to fit some data into the virtual machine, which is it's always a tricky thing to do because from the OpenNebula perspective, all the virtual machines are like black boxes. OpenNebula doesn't want to mess what's inside your VM, primarily because it's really difficult to support all the varieties of guest operating systems that you can have. And for Unix, Linux, we might be okay, but when we get to Windows, we don't have the expertise. So we don't want to get inside the VM. We just want to be able to feed it data, and then it's up to the user when the VM is booted to make use of that data or not. Okay, so that's from the virtualization management point of view. User may want also to do some storage management, so he will want to have a catalog of images where he can use to build virtual machines out of. He will want to prepare the virtual machine, the images themselves, and then probably upload it, or maybe even he wants to use one of the predefined golden images that the cloud administrator may have prepared for him, so that the predefined appliances. And he may want to use, apart from operating systems, some other kind of images like data blocks, and making them persistent, so the next time he boots a VM with the same data block, he will have this information available. He will want all that to be managed for themselves. He will expect that anyway. Okay. He will also maybe want to keep track of how much computer power and capacity he is using. So he may want to have some sort of accounting information available, ideally from a graphical form. And he may also want to, he will obviously want to have some kind of debugging mechanisms. If the VM is not booting or is not getting the correct network interface, I want to be able to know why. So he may want to have some kind of BNC connection directly to the virtual machine. And once it's up and running, he may want to do an SSH connection or a remote desktop connection if it's a Windows machine. What else? He will want to have some network management. He will need his VM to be able to connect between them or to the internet. So he will need kind of a manager of a network catalog. He will need probably to assign some public or elastic IPs to his virtual machine. He also may want to have their virtual machines completely isolated from other users. So the model will be to have a cloud that allows multi-tenancy, so multiple users can use the same infrastructure but in a completely isolated way, so they don't see each other, they don't bump into each other. And he may also want to set some firewall rules. So, okay, this virtual machine is going to be accessible from port 22 and nothing else. Okay, so how can he manage all of this? What are the available interfaces that the user will be able to use to manage these different aspects of a cloud infrastructure? Well, in OpenNebula, he can decide between 3 different interfaces. One of them is it's a subset, really. It's not a complete Amazon Web Services interface. I'm referring here to just EC2. But he may, if he has already some applications that make use of this interface, he doesn't have to port it somewhere else. If he wants to use an OpenNebula-based cloud, he can use the Amazon EC2 interface. And that's de facto standard in cloud computing nowadays. Also, he can use one of the recommended standards by the Open Grid Forum, that is the Open Cloud Computing Interface, OCCI, which is, I think, much more powerful than Amazon EC2 because it allows you to manage more resources than the Amazon EC2. So you can define networks, you can you can manage all the images, and with more, I would say, more detail that the Amazon interface offers. And on top of this OCCI, I mean, both of them are services that are managed through the command line. But on top of OCCI, OpenNebula offers the OpenNebula self-service portal, which offers the basic functionality a user should expect from a cloud. Basically, managing images, managing networks, and managing virtual machines. That's it. I mean, completely hides all the details of the infrastructure. It doesn't show any physical hosts, or user doesn't have to care about what software breaches are mounted in each host, or what are the data stores where the images are pulled from. He doesn't care about that. He needs some abstraction, and the OpenNebula self-service offers means to do that. Okay, so that was the user perspective. What's the cloud provider perspective? Cloud provider can think of a cloud provider as the cloud administrator, the one that enables his infrastructure to be able to use to be used in a cloud-like fashion. Okay, so what are the main components to build a infrastructure? Well, we got it there visually. Let's go through them. You will want to have a sort of front end access point to the cloud, and he will need to be able to manage things like authentication and authorization of the users. He doesn't want everyone to come here and just use all the computer power he has. No, he wants to be able to control that using some kind of groups or access control lists or roles. He also will need some form of accounting if he wants to keep track of who is using what. Obviously some logging if something goes wrong, if there's some intrusion or whatever. He will need to have somewhere where all the events are logged in files or any other way. And he will also be interested in set some kind of quotas. So just restrict the access to users, saying, okay, you just have access to 2 CPUs and 4 gigs of RAM for this week. So he will be able, he needs to set that kind of quotas, that kind of rules. He also needs to have physical hosts. He needs to have the servers, the capacity. He may want to use different hypervisors for different reasons. He may want to use VMware, he may want to use Oracle, Hyper-V, whatever. So OpenNebula out of the box just natively manages KVM, Shen, and VMware. But if you go to the OpenNebula ecosystem, which is projects that are hosted but are not really inside the main distribution, you can find the prototype drivers for Shen Server, for Hyper-V, VirtualBox, I think, a number of others. With one instance of OpenNebula, he will be able to manage up to 500 hosts. These numbers came out of some testing made out by the CERN, which managed to deploy 16,000 VMs in 500 hosts, and OpenNebula didn't crash. That was the good news. He will also want to have some form of automatic failover and high availability. He doesn't want the front end of OpenNebula crashing and so the cloud going astray. He doesn't want to have one physical host down and all the VMs on that host to disappear completely and not having automatic means to launch those VMs again in another host. And he will need to have some kind of automatic resource allocation, meaning scheduling. He will need OpenNebula to be able to say, okay, this VM has this capacity, this host has this capacity, is the best fit, so I'll send it to it. And also he will need to manage resource pools of the different resources that conforms a cloud. Okay, he will need to have some kind of service networks as well for monitoring and control, to performing live migration, to access the storage servers, which bring us to the data stores, which are places where the images reside, right? Where they are pulled from by OpenNebula and staged into the host where the virtual machine is going to boot. So he may want to use multiple data stores. He may have heterogeneous configurations. He may want to use shared file system or not. So as you see, these are the basic blocks, but they are source of heterogeneity. I mean, there's lots of possible combinations, and what the OpenNebula philosophy is about is not closing doors, not saying, okay, you just have to use what this implements, but trying to be more flexible, which makes it more difficult to configure, but I guess a bit powerful as well. Okay, so this, okay, looks a lot like the one before, right? But yeah, here, maybe the difference is what's being supported by OpenNebula right now. Okay, so for instance, networks, we have VLANs, so you can do some kind of traffic shaping at layer 2. And we also support Open Switch and EV tables. In the front end, for authorization purposes, you can use for the user authorization and authentication the certificates X509. Can use LDAP servers, so you don't have to map your users in your enterprise to OpenNebula users, but that mapping will be made automatically if you use a LDAP server or you use any other form of authorization that you want to integrate with. The scripts for authorization are quite easily made, so you can maybe think about doing some for yourselves to, I don't know, connect to Kerberos or things like that. So out of the box, we have certificates, LDAP, and also SSH keys, so you can authenticate your users by those means. You can set ACL roles or groups for the users. You can use, as I said, VMware and Sheng and KVM as the hypervisor. And for monetization, you can use Ganglia or you can use Nagios. Or you can use just what OpenNebula offers, which are simple probes that through SSH goes to the host and retrieve information of the host. It's not as scalable as maybe one of those other solutions, but if your cloud is mid-side, you'll be good to go with that. For the data stores and the transmission of images to from the servers to the hosts, you can use distributed file systems as NFS, which is maybe not the best option. You can use ClusterFS as well. You can use ESCSI and LVM to automatic provision without transferring images, but rather through Ethernet ESCSI. And you can use some other means like SSH, which is the out-of-the-box solution, and also some others that are living in the ecosystem, like for instance BitTorrent, to fastly distribute your images. This is especially good if you have to distribute the same image across different hosts and you don't want to use any distributed file system, which at the end of the day always acts like a bit of a bottleneck. Okay. So, also from the cloud provider perspective, it would be interesting to kind of group together the physical resources by similar characteristics, right? So maybe someone has, I don't know, a group of physical hosts that are really, really, really well connected by a really good network layout. And then you have another host that are not that good connected, but they have a lot of storage. Okay, so you maybe want to cluster those in fast network cluster and the big data cluster, right? So with OpenNebula, you can do this kind of stuff, and you can build or tune the scheduling policies to honor that. You can even tell the user, well, you have these clusters available, and you can choose where your VM goes just by setting one option in your VM template. This can be used for load balancing, also for high availability and high performance computing, or means to squeeze the most out of those. Also, you can have multiple data stores per cluster. This is a new feature, really. I mean, this is just available in the latest version, which is 3.4, and it allows you to balance input-output operations between different storage servers, which is, I guess, interesting. And well, you can define different SLAs for backups and performance features for different virtual machines or different users. Okay, one of the interesting things you can do with OpenNebula is managing different OpenNebula instances. So from the cloud provider perspective, this can be really useful. He wants to have a centralized way to manage different clouds that live in different administrative domains. He can use the Ozone server. An Ozone is an OpenNebula zone, meaning it's an OpenNebula instance. What is that? What an OpenNebula zone server offers is ways to decouple the access to the different clouds, right? So he can, I mean, it can, in a way, what it does is proxying the requests to different clouds. When you add that zone inside the Ozone server, you have to give the root credentials of the OpenNebula installation. And once you get that, you can define virtual data centers within an OpenNebula zone, meaning that you can pick a subset of resources and build a virtual data center that will be offered to the end user. So the end user will be able to log in through the graphical user interface that offers OpenNebula, and he will not connect directly to any of these zones, but rather he will connect to an Ozone server that will be reverse proxying his petitions. So all the details, even the location of the cloud, will be hidden from the user. You have a centralized, as I said, way of controlling all these resources using the portal, or also the command line interface that also comes with the OpenNebula distribution to manage the Ozone servers. It allows to do some kind of raw federation of clouds. I mean, you are not getting means to live migrate a virtual machine between zones, or you're not getting automatic translation of images between two sites. But you get a really nice way to do multi-tenancy and to manage subset of resources and offer them to the end users. You also have isolation of these virtual data centers. So basically, when you create a virtual data center, you get the figure of the virtual data center administrator, who is able to create new users just inside the virtual data center with just access to a subset of the resources that you define when you define the virtual data center. So they cannot get out of that. And also gives you management of multiple sites in a multi-tier architecture. So this is more or less what it looks like. The architecture of the Ozone server is depicted here. We basically have two pools, one pools of zones and one pools of VDCs. And on top of that lives a REST server, a very simple REST server that you can interface using command line interface or a graphical user interface. So what you can do is add different zones. These are like OpenNebula instances, and the pool of resources is managing. So here you can see that this zone, for instance, has two clusters. When I define a virtual data center, I divide this cluster in a further subset. So this will be the resources accessible by those users. He will be able to use only these BDC blue resources. As you can see, you have the figure of the BDC admin. That is the one that creates the networks and creates the images for the users and gives them rights to use them or not. And then you have the figure of the cloud admin that is the one that controls really the resources in this site. He can, I mean, if he's fed up with the Ozon's administrator, he can just change the password and that will be it. This is kind of a typical scenario in large organizations and cloud providers. This kind of tries to mimic the functionality offered by other products like vDirector, I think it's called, and offers the demand, provision, and fully configurable and isolated virtual data centers with full control and capacity to administer its users and also the resources. So, yeah, this is, you can think of it of a product to manage different instances of OpenNebula in a centralized way. Okay, so what else a cloud administrator may want to do? He may want to be able to grow beyond the capacity of his physical infrastructure, right? So if he's offering his infrastructure to users and he noticed that he cannot cope with that, he may want to be able to grow in a public cloud provider like, for instance, Amazon EC2. This is what is being called cloud bursting, and it allows the cloud administrator to cope with peak fluctuating demands of infrastructure. This is not maybe the perfect hybrid cloud, because OpenNebula will be able to launch and manage the lifecycle of virtual machines, but it's not yet able to upload the image, transform the image that is working in the local infrastructure and upload it to Amazon EC2 and expect that everything is going to work as if it's in local. So some previous work needs to be done. For instance, one of the use cases we have for hybrid cloud is, I don't know if you're familiar with SandGrid Engine, which is basically a cluster batch processing software that is able to manage a cluster of worker nodes to basically calculate HPC things like, well, anything really. So the use case was to have the master node of the SandGrid engine running here locally with some slaves and having some service manager just monitoring the load of this SandGrid engine. So when it realizes that the physical infrastructure cannot cope with the new demand, OpenNebula just launches some pre-configured images in Amazon. These images are contextualized by OpenNebula, so they are able to call home, right? So they are able to do a VPN connection to the master node of the SandGrid engine and enroll to it and saying, okay, I'm here, I'm able to do some work as if it was in the same LAN, but obviously it's not. I'm saying this is not the perfect solution because the latencies are really high. So, but there's not really any way around that. So it can be useful for some cases, but it's not for every service really. Okay, so how does the cloud provider interact with his own infrastructure? Well, he has also several choices. He can use a command line interface that are small programs to manage the different resources offered by OpenNebula. So you can have one VM that controls the lifecycle of the VM. You can have one host that is going to be used to add physical host to the infrastructure, and a number of others. Or the cloud provider can say, okay, I don't like the command line interface, so let's go for something graphical. So you can get the OpenNebula Sandstone, which is as powerful as the command line, meaning that it gives you access to all the resources in your infrastructure, being that physical or virtual resources. So you can manage all the aspects of the infrastructure from a web browser. You can also choose to have some custom-made scripts to be able to automate the common tasks. So he may want to look into the XML RPC, which is the native API offered by OpenNebula, or he may want to use some higher-level API like the OpenNebula Cloud API, which has bindings now, I think, for Ruby, Java, and Python, and offers some mechanisms that maybe with the XML RPC are more cumbersome to do. Okay, so let's move to the cloud integrator perspective. So what's the cloud integrator? What's the cloud integrator expecting from a component like OpenNebula? So if you think about the cloud integrator as someone that wants to build a cloud solution with more functionality than what OpenNebula offers, maybe he wants to offer the combined solution with also some other storage or some other billing platform or whatever else, what he will expect from OpenNebula to be easily integrated with. Well, he will expect to be truly open, so with OpenNebula you get Apache license. You expect it to be very adaptable, so very modular and extensible. You can see here, this is a peek on the architecture of OpenNebula. You can see how everything is really modular. So you have a core which only works on abstractions. On top of that, you have the XML RPC API. That is the one that uses the scheduler, which, as you can see, it's another component. So it's a different process completely that just gets information from the core and make the scheduling decisions. On top of the OpenNebula Cloud API, you can interface that using the command line interface, some graphical user interface, and also the cloud servers like the OCCI and the Amazon EC2. And the interesting part is underneath. So that's how you access OpenNebula, and what OpenNebula does with the different resources are also, I mean, the tasks are carried out by plugins, right? So the core just talks with different processes using a simple ASCII protocol. Well, he calls that to make monitoring of the physical hosts and also the virtual resources. He calls one of those as well to be able to launch a machine and to stop it with different hypervisors. So, for instance, if OpenNebula wants to shut down a machine, he will tell the driver, okay, shut down this machine. And the driver will say, okay, this machine is running on KVM. Okay, I'll call the KVM script. That's more or less how it works. And then you go into the KVM script, and it's a really simple script that you can change, modify. It's probably, the KVM one is written in shell script, but you can write it in Ruby, and you can extend it, and, well, it's really, really modular. And you got the same for any other aspect, like storage, the transfer of images, the networking, and also the authorization. So you can build and modify maybe the LDAP authorization module to be able to cope with groups, which now it doesn't. So that would be a task that you can do without having a knowledge of all the OpenNebula core and the complexity you might have. You will have just to modify a simple script with a really simple interface. It's basically maybe a couple of parameters and a really simple answer. If you do that, then you can integrate that with OpenNebula because it's going to understand it completely. And well, also you can see here the database, which is basically something that handles the persistency. So if the OpenNebula host crashes or the OpenNebula daemon crashes, you can launch it, and he will be able to interface all the running virtual machines, and they won't be disrupted. Okay, so these are the features that OpenNebula offers for cloud integrators, right? So as I said, he offers different interfaces. He may want to integrate OpenNebula with different accounting and billing platforms. He may want to use a new self-service portal or customize the one that comes with. He may want to tune the hypervisor interaction, or he may want to develop new drivers for new hypervisors. He may want to try some new hybrid configurations with different cloud providers not currently supported. He may want to try out new information systems, like he may want Nagios or Ganglia. He may want to integrate with something else. He may want to also extend the monitoring pros that OpenNebula has to take into account some other factors like, I don't know, the temperature of the CPUs that are running in the physical infrastructure. He may want also to integrate with some other SAN or NAS solutions to tune the storage operations to fit more some kind of infrastructure configuration. He may want to use external repositories to, like appliance marketplace, for instance. He may want to integrate the authorization mechanisms with new systems, like, for instance, Active Directory, or to tune ACLs, or to custom, in general, authentication. So what OpenNebula offers for this is an architecture that is modular, and also documentation on how to develop new integrations for OpenNebula. Okay, so also from the cloud integrator perspective, it can be interesting to have a look into the ecosystem to see what different integrations have been done by other people and contributed back in the form of ecosystem. So these projects are hosted in OpenNebula, but they are not controlled by OpenNebula, by the OpenNebula people. They are they can have different licenses. They can, well, pretty much it's up to the author of the software to do whatever he likes with it. You can see that even in the ecosystem, there's a clear focus on standards, right? So thanks to third parties, OpenNebula can be accessed with different formats, like maybe OVF, or can manage also storage that are offered using the CDMI, or you can even interface OpenNebula using the vCloud interface from VMware. You can also see that there's adapters to be able to interface with other cloud providers like DataCloud, which offers a wide range of interfaces from Amazon EC2 to, I think, Rackspace and lots of others. It's also integrated with G-Clouds and LiveCloud, so those are different mechanisms that are available in the ecosystem to access OpenNebula in different ways that may be interested for the cloud integrator. Also, not directly supported, but hosted in OpenNebula and compatible with it. You can find some virtualization drivers like the SenCloud Platform, Hyper-V, OpenVisit, and also a DeltaCloud adapter. So you can not only interface OpenNebula with DeltaCloud, but you can use DeltaCloud to access other infrastructures. You can also find some examples of integration with configuration tools like CF Engine, Puppet, and Chef, and solutions to integrate OpenNebula with other storage backends, like, for instance, the Swift one of OpenStack or BitTorrent as well. It can be used. Okay, so it's a brief peek on the OpenNebula history. It started with DSA research group in 2005, starting to research on virtualization technologies, and 3 years later, the first technology preview of OpenNebula got out. So talking about 4 years ago, and in the middle of that year, the first stable version got out, and from there, we tried to push it into the main Linux distribution. So nowadays, version 3.4 will be available in Fedora 17 and in OpenSUSE, Debian, Ubuntu, and we are trying to push also into the Apple repository. Somewhere around the middle of 2010, a company, a spin-off, was born. It's called C12G Labs, that offers commercial support for OpenNebula. So what you got from the community is a best effort mailing list. What you got from C12G is engineers that can customize your OpenNebula installation, and also offers a ticketing support system with SLAs. Okay. Oh, well, it's interesting to know the European funding of the project. It started as an outcome of a project called Reservoir, which was a European flagship project with I think 17 partners and a lot of money to fund. And from there, it's a tool that is used in a lot of European projects as well. But I think I have some slides on that. So these are a bit of numbers on the health of the community. It's good to note. I think it's good for OpenNebula to note that since the project started, the interest is growing all the time, right? So we got more than double of annual growth each year regarding the downloads of the software, which a good indicator. Also site visits, the mailing list, which is it's a big effort to maintain. But if you have an open source project and you want to foster adoption, you have to be very careful with that. I think we have, as I said, there are 800 registered users, which are, I guess, a good mailing list. Especially if you look at how much we're spending in marketing, which is none. Okay. So who uses OpenNebula? Well, OpenNebula can be seen as a cloud enabler in the ICT industry. It's not just meant for the cloud administrator that wants to build a cloud, but also for big companies that are interested in build cloud solutions out of OpenNebula. So we can see that it's enabled hosting companies and telcos all over the world, like China Mobile, Telefonica. They are using OpenNebula for their own solutions and also for in-house managing. Some others are less known, but also big contributors to the OpenNebula community, like Alterways and VStorm. It's also an enabler to companies that want to offer cloud solutions. So we can see there people that uses OpenNebula to offer cloud solutions to other clients, and also it enables service company to offer cloud consulting and integration, like for instance Logica, which is a technological partner of C12G, I think, KPMG, lots of them. It's also a cloud enabler for building virtualized data centers. So there's big players in the industry that are using OpenNebula to offer their services. Most remarkable is the case of Vim, which is a big contributor of OpenNebula. Also, there's cases in e-government of people that are thinking about using OpenNebula, like for instance in Florence, in Wyoming, even in my hometown, they're thinking about using OpenNebula to manage the physical hardware in government. It's also used by supercomputing centers like Vázques, also SARA, which is I think based in the Netherlands, and also especially for research centers like CERN, which is a big user and the one that provide the best feedback in scalability tests. The Fermilab, the ESA, lots of research centers that contribute and are active in the mailing lists. Okay, about European projects, we participate in a number of them nowadays, like distributed computer infrastructures, like for instance Bonfire, which is a project to offer cloud computer to scientific communities, and also some other research projects like Reservoir, which just finished, but is the one that originated all the OpenNebula project, Also, a Stratus lab that is trying to bring together the worlds of grid and cloud, and a number of others as well. Okay, so that's, I think, about it. This is the main page of OpenNebula. You can go there for further information if you want to, and also to try it out if you're up to it. Now I'll be happy if you have any questions.
Anyone?
Okay, thank you.
Thank you very much.